Thank you for connecting with us. We are going to consider how we can use the addition rules of probability to calculate probability. So let A and B represent events in the same sample space. So if A and B are mutually exclusive events, as in over here, then probability of A or B is equal to probability of A plus probability of B. So it means there is no intersection. The two events cannot occur at the same time. So in this case, we can see that A intersection B is a null set. Now, when we come here, if A and B are inclusive events in the same sample space, then probability of A or B will be equal to probability of A plus probability of B minus probability of A and B. So in this case, the intersection is not a null set. There is an intersection for A and B. Let us illustrate with this example. Let S equal natural numbers less than or equal to 100. What is the probability of choosing at random a number less than 11 or greater than 90? So S is a set of natural numbers less than or equal to 100. So S will have elements 1, 2, 3 up to 100. And this implies that the number of elements in this sample space is 100 elements. Now we want to find the probability of choosing a number, and the number of elements in this set will be 10. Then also we let the event B be equal to number greater than 90. So we have 91, 92, 93 up to 100. So we can see clearly that A intersection B is a null set. Then we can find probability of A or B, which is equal to probability of A plus probability of B. This is a mutually exclusive event because A intersection B is a null set. So probability of A will give us the number of elements in A over number of sample space. The probability of B will be number of elements in B over the number of sample space. So this will be equal to, let me continue up here. Sorry. So this will be equal to, so probability of A or B will be equal to number of elements in A is 10 over number of sample space, which is 100. The number of elements in B is also 10. So we have 10 over 100 as well. So that will give us 20 over 100, which is equal to 1 over 5. The B part of the question, a number less than 11 or an even number. So again, we let event A be number less than 11. We have 1, 2, 3, up to 10. The number of elements in this sample space, in this set, will be 10. Then we let event B be equal to an even number. So even numbers will start from 2, 4, 6, and so on, up to 90, up to 100, up to 100. So can we find A intersection B? Is there any element in both A and B? Let's find out. So there's 2 here, there's 2 here, and there's going to be 4 common. There's going to be 6 common to both. There's going to be 8. There's going to be 10 as well. So for this, we have the number of elements in the set B being 50. Then the number of elements in the sets A and B will be equal to 5. 1, 2, 3, 4, 5. So in this case, the probability of A or B will be equal to probability of A plus probability of B minus probability of A and B. So this will be equal to probability of A is 10 over 100 plus probability of B will be 50 over 100 minus 5 over 100. So this will simplify to 10 plus 50 is 60 minus 5 is 55, so 55 over 100. And this will simplify to 11 over 20. We have another example here. A spinner is divided into 4 equal portions: colored red, blue, green, and yellow. If the spinner is spun, find the probability that it lands on blue or yellow. So we have the sample space. We have red, we have green, we have blue, we have yellow. So probability of blue or yellow will be equal to probability of blue plus probability of yellow. Probability of blue is 1 over 4 because the number of elements in this sample space is 4. And probability of yellow is also 1 out of 4. And that will give us 2 out of 4, which is equal to 1 over 2. Then let's take this one. Numbers are written on cards. The cards shuffled and one is selected at random. The outcomes for this experiment and event A and B are shown in the Venn diagram. List the sample space. So the elements in the sample space are 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the elements in the sample space. Then we are supposed to find probability of A, probability of event A. We know that will be number of elements in A over number of elements in the sample space. So number of elements in A, we have 1, 2, 3, 4, 5. So 5 over 9. Then we also asked to find probability of B, which is number of elements in B over number of elements in the sample space. And that will give us B, we have 1, 2, 3. So we're going to get 3 over 9, which is the same as 1 over 3. The probability of A and B, so element in A and B, so number of elements in A and B over number of elements in the sample space. So we have 1, 2. That will give us 2 over 9. And we are supposed to calculate the probability of A union B. So probability of A union B is equal to probability of A plus probability of B minus probability of A and B. So that will give us probability of A is 5 over 9. Probability of B is 3 over 9 minus probability of A and B 2 over 9. And that will give us 5 plus 2, 5 plus 3 is 8. 8 minus 2 is 6. So 6 over 9, which will simplify to 2 over 3. Now, if you want to do this directly without using the addition rule of probability, then you have to find the number of elements in A union B, then express it over the number of sample space. The number of elements in A union B are, we have A union B, A union B will be equal to 1 element in A are 1, we have 3, we have 5, we have 7, then we have 6, then we have 9. So how many elements are here? 1, 2, 3, 4, 5, 6. So that will give us probability of A union B will be equal to number of elements in A union B, which is 6, over number of elements in the sample space, which is 9. And when we simplify this, you get 2 over 3. So you see the addition rule, it works perfectly. Here's another example. The table shows the distribution of student marks in a test. If a student is chosen at random, what is the probability that the student scored 3 or 1? So probability of student scoring 3 or 1 is equal to probability of the student score 3 plus probability of the student score 1. And that will give us the number of students who scored 3 are 9. So number of students who scored 3 over number of elements in the sample space plus number of students who scored 1 over number of elements in the sample space. We don't have an intersection here. So this will give us 9 over the sample space. When you add all these 3 plus 2, 5 plus 4 plus 9. So that will give us 18. 18 plus 9 will be 27. So 29 over 27 plus number of students who scored 1, they are 2, plus 2 over 27. And that will give us 11 over 27. Then probability that a student scored 2 or 3 or 4. So we can extend the addition rule for probability. Probability of 2 or 3 or 4 will be equal to probability of 2 plus probability of 3 plus probability of 4. So that will be equal to number of elements scoring 2 over the number of elements in the sample space, number of elements scoring 3 over number of elements in the sample space, plus number of people scoring 4 over number of elements in the sample space. So number of elements scoring 2, they are 4. So 4 over 27, add it to number scoring 3, 9. 9 over 27, then add it to those squaring 4. 5 over 27. And this will be equal to 4 plus 9 is 13 plus 5 is 18. 18 over 27, which is the same as 2 out of 3. A bag contains 40 identical marbles in a box. 18 of the marbles are blue, 14 red, and 8 green. What is the probability that a marble selected at random is either blue or green? So over here we have the sample space, the number of elements in the sample space. Number of elements in the sample space is 40. Then number of elements that are blue, we have 18. And number of elements that are green, we have 8. So we have to find probability that the marble is blue or green. So that will be equal to probability of choosing a blue marble plus probability of choosing a green marble. And that will be equal to 18 over 40 plus 8 over 40. So this will give us 26 over 40. And that is equal to 13 over 20. Please, I want you to try the B part and see whether you get 4 over 5. So remember, these are mutually exclusive events. Let's take this one. If two events x and y are mutually exclusive, probability of x equal 3 over 5. Probability of y is 1 over 4. Find probability of x and y. So we know that if the events are mutually exclusive, then x intersection y will be the null set, the empty set. So number of elements in x intersection y will be equal to 0. So probability of x intersection y will be equal to number of elements in x intersection y over number of elements in the sample space. So that will give you 0 over a non-zero number, which is going to be 0. Then B, probability of x in y will be equal to probability of x plus probability of y, because the events are mutually exclusive. So that will give us probability of x is 3 over 5 and probability of y is 1 over 4. The LCM is 20. So 5 into 20, 4 times 4 times 3, 12. Then 4 into 20 is 5. 5 times 1 is 5. So that will give us 17 over 20. Thank you for connecting with us to